Critical value t-test for the mean, chapters 9 and 11. Example, in a sample of n1 or n equal 21 sedentary people, the mean glucose level x bar 5.2 milligrams per deciliter with a standard deviation s of 0.4 milligrams per deciliter. This sample is taken from a larger population where with millions of sedentary people, where the mean mu is unknown, standard deviation sigma is unknown. We want to compare this to the general population with mean mu 0, 4.8 milligrams per deciliter, and standard deviation sigma 0, 0.5 milligrams per deciliter. Okay, so with 95% confidence, we want to test H naught, mu equal 4.8 milligrams per deciliter. Sedentary glucose level is the same as that of the general population versus the alternative, mu not equal to 4.8 milligrams per deciliter. Sedentary glucose is different than that of the general population. So this is a two-sided alternative. The confidence level 95%, or as a decimal, is 0.95, represented by 1 minus alpha, and alpha would be the level of doubt. 1 minus 0.95 is 0.05. That's the level of doubt, or it's also called the level of significance. Step 1, we'll look in row n-1, which would be row 20 of the t-table, and the column would be the doubt divided by 2, which is 0.05 divided by 2 is 0.025. Looking at that column, and to get our critical value of 2.086. And so we will reject H naught if the t-score from the data is either more than 2.086 or less than negative 2.086. The test statistic is going to be, it's almost the same formula as the t-score, except this is a z-score rather, but this is a t-score. It's a score minus the mean and divide by the standard deviation, but we have to adjust for the sample size also. So it's x bar minus mu naught times the square root of n over s. Fill in the numbers. 5.2 minus 4.8 times the square root of 21 over 0.4 is 4.583. And because our test statistic of 4.583 is more than our upper critical value of 2.086, we reject H naught with 95% confidence and conclude the mean sedentary glucose is different from that of the general population. We can also estimate a p-value. Modern researchers tend to emphasize p-values. In the past, not so much, because p-values before we had computers were sometimes hard to compute. But these days with computers, p-values are computed. We can estimate it from the t-table. The t-table is really not set up to give p-values, but our test statistic is 4.583 is more than any number in row 20 of the t-table, and because of that, our p-value has to be less than 0.01, and provides strong evidence that the sedentary glucose mean is different from that of the population mean. And these hypothesis test formulas for the mean are valid if either n is at least 30 or the variable is normal. Now, our test here was a two-sided test. It might make sense in this situation to do a one-sided test. If we suspect that the sedentary glucose is not going to be less than that of the general population, if anything it would be more, we could do a right-tailed test, and again, alpha will take 1 minus alpha to be 0.95, alpha is 0.05, H naught, mu equal 4.8 milligrams per deciliter, same hypothesis we had before, but the alternative here we can put a greater than symbol. The alternative HA, mu is greater than 4.8, sedentary glucose level is more than that of the general population. And step 1, we want to go to the t-table, and this time instead of looking in column 0.05 over 2, we're going to look at just column 0.05, because we're going to put all of our doubt on one side rather than split it between the two extremes. And we get the upper critical value of 1.725. And again, we've computed our test statistic. It's the same computation we did before. Again, 4.583 is more than our upper critical value, and the difference is even greater this time. So again, we reject H0 and conclude that the mean sedentary glucose level is more than that of the general population. If prior to collecting the data we were certain that the mean glucose level was not more than that of the general population, we could do a left-tailed test. That probably doesn't really make too much sense in this situation. It probably does not make sense that sedentary people would have a lower glucose level, but we could test that. So in this time, since we use the left tail, our critical value is just take the opposite sign. It would be negative 1.725, and our test statistic is 4.583. And because it's more than our lower critical value, we fail to reject H0. In order to reject H0, it has to be less than our either more than our upper critical value or less than our lower critical value. So in this case, we fail to reject H0. Sample does not provide enough evidence to conclude the mean sedentary glucose level is less than that of the general population. Okay, so we can also test the variance, and we'll set the same level of confidence, 1 minus alpha equal 0.95. Test H0, sigma squared equal 0.25. Sedentary glucose variance is the same as that of the general population, versus the alternative, sigma squared not equal to 0.25. Sedentary glucose variance is different than that of the general population. Now the distribution for the sample variance follows a chi-square distribution, which is not symmetrical. So we have to we can't just change the sign of the upper critical value to get the lower critical value. We have to look up each number in the table, this is a two-sided alternative. So we'll look up two numbers in the table, and we'll put half of the doubt on each side. So our level of doubt is 0.05. 0.05 divided by 2 is 0.025. So that's how much doubt we want to put on each side. So using the chi-square table in the appendix, we look in row 20 and column 0.975. We get critical value of 9.591. And if we look in row 20, column 0.025, we get critical value of 34.170. And then we can compute the test statistic to compare that to the critical values. N1 squared times N1 times S squared over sigma naught squared, 20 times 0.4 squared over 0.5 squared, 12.8. And because our test statistic is between the two critical values of 0.9 and 34, we fail to reject H0. Sample does not provide enough evidence to say that the variances are different. Okay. We could also test whether the standard deviations are different, and it's actually the same test as the test for the variance, so it's the same conclusion, and there's no additional computation that's needed. And these hypothesis formulas for the standard deviation and variance require that the sample be from a normal population. Okay, so here we could also do a one-sided test for the variance. If prior to collecting the data we are certain that the sedentary glucose variance was not less than that of the general population, we can do a right-tailed test. It looks like I'm frozen here. Wait for me to unfroze. There we go. Okay. So H naught sigma squared equal 0.25. And the sedentary glucose variance is the same as that of the general population versus an alternative sigma squared greater than 0.25. Sedentary glucose variance is more than that of the general population. This time we do not divide by 2. We want to look in row 20 in column 0.05 with the chi-square table, and we get 31.41, and the test statistic is 12.8, same as it was before, and because our test statistic is less than the upper critical value, we fail to reject H naught. Sample does not provide enough evidence to say that the sedentary variance is higher than that of the general population. The test for the standard deviation is the same. There's no additional computation needed. If prior to collecting data we're certain that the sedentary glucose variance was not more than that of the general population, we can do a left-tailed test. So H naught is the same. Sigma squared equal 0.25. Sedentary glucose variance is the same as that of the general population. The alternative HA, sigma squared less than 0.25, sedentary glucose variance is less than that for the population. So the lower critical value, we look in row 20, column 0.95 to get 10.851, and our test statistic is 12.8, and 12.8 is more than the critical value of 10.851, so we failed to reject H naught. Sample does not provide enough evidence to say the sedentary variance is lower than that of the general population. And again, we could do the same test for a test of the standard deviations. There's no additional computation needed. We can also estimate a p-value. In row 20 of the chi-square table, the closest number to our test statistic of 12.8 is 12.443. This number appears in the 0.90 column, so the p-value would be a little bit more than 1 minus 0.9 or 0.10, which indicates little evidence that the sedentary glucose standard deviation is higher than that of the general population. And that concludes this presentation.